For closing bins, hoppers and silos containing powders or granular materials, or to close screw conveyor outlets, butterfly valves still are and always will be among the most widely used equipment. What used to be custom-built items for specific applications have been turned by WAM into a mass-produced industrial product with features that allow versatile use. 3 independent ranges of dust-proof valves are available according to the customer's requirements. The VFS valve, which consists of 2 high-pressure die-cast semi-bodies made from aluminium alloy, a steel core disc coated with WAM's unique polymer composite Syntel, and a pre-tensioned elastomer seal. The VFA valve has the same basic design as the VFS. Its seal, however, encloses the top and bottom flange as well as the inside of the valve body entirely. The V2FF valve, which is used exclusively as a silo discharge device, is made from a single-piece fabricated carbon steel body lined on the inside with WAM's polymer composite Syntex. The incorporated upper square flange can be adapted to different sizes of silo outlet flanges. The valve disc is made of surface-treated carbon steel. The main innovative features of WAM butterfly valves are: in the case of VFS, steel core discs coated with FDA-approved polymer composite Syntel. In the case of VFA, all contact parts made from FDA-approved food-grade polymer composite Syntel. In the case of V2FF, the valve body, lined internally with polymer composite Syntex, ensures better sealing when the valve is closed. VFS valves are available in 2 versions. V2FS with identical top and bottom flanges, and V1FS with a top flange and bottom piece suitable to be fixed to a flexible sleeve connection. Both versions cover a range from 100 to 400 mm nominal diameter and are guaranteed at a maximum pressure of 0.2 bar. VFA valves are only available in the double flange version V2FA, ranging from 100 to 300 mm diameter, and are also guaranteed at 0.2 bar. V2FF silo discharge valves are available with either 250 or 300 mm nominal diameter, with square top flange and round bottom flange suitable for WAM's universal screw feeder inlets. The series production of tens of thousands of valves and actuators guarantees high quality and a particularly favorable price-performance ratio. WAM's actuator range, including manually operated levers, electro-pneumatic and gear motor drives, represents the ideal complement to the valves. Production at an industrial level requires quality assurance at each stage of the manufacturing process. Starting from inbound quality control through laser cutting and robot welding of steel parts, through final assembly and testing, up to outbound quality control and packaging, as being certified according to ISO 9002 quality system. Quick delivery is guaranteed thanks to a large amount of stock carried at the WAM factory in Italy and at its worldwide subsidiaries. During the following part of this video, please pay attention to the special safety notices. On receipt of the consignment, check that the codes on the cardboard packaging of the valve, the actuator and the position signaling device, if supplied, match with those in the invoice and in the acknowledgement of order. Handle all material with care. Remove all parts from their packaging. Note the assembly instructions contained in each package. Put the valve on a level surface so that the writing on the disc points upwards. Remove the protection from the disc shaft. Assemble the lever setting mask with a large sight pointing upwards using the 2 bolts supplied. Mount the lever with a bent part pointing towards the mask onto the splined disc shaft, ensuring the lever is placed in the closed position. Fasten the lever using the bolt, washer and knob supplied. In this case, put the valve on a level surface so that the writing on the valve disc points down. Remove the protection from the disc shaft. Before fitting the pneumatic cylinder, ensure the piston is fully retracted by turning the shaft with the aid of a spanner, either to the left or to the right, as far as it will go. Now mount the pneumatic actuator, which has been pre-assembled complete with its accessories as shown in the video on actuators, onto the splined disc shaft, keeping it in a horizontal position and pointing to the right. Carry out test operation. Never put your hands between the disc and the valve body while the valve is working. Do not expose parts of your body to the compressed air jet. Follow general safety instructions. If the valve disc does not close completely, even though the piston is fully retracted, disconnect the compressed air supply, loosen the large nut and the socket screw at the opposite end of the actuator and push down the valve disc until it's fully closed. Then turn the socket screw clockwise until you feel some resistance and fasten the nut in order to block the socket screw. Put the valve on a level surface so that the writing on the valve disc points up. Ensure that the actuator is at the end of the stroke by turning the shaft anti-clockwise with a spanner as far as it will go. Mount the actuator onto the splined valve shaft, keeping it square. Fix the actuator with the supplied bolts and tighten them according to the supplied instructions. Connect the solenoid valve with the compressed air supply and carry out test. Never put your hands between the disc and the valve body while the valve is working. Do not expose parts of your body to the compressed air jet. Follow general safety instructions. If the valve disc does not close completely, disconnect the compressed air supply and adjust the position of the end of stroke using the nut and bolt on the lower right part of the actuator. Remove the protection from the disc shaft. Push down the valve disc until it's completely closed. Mount the gear motors square onto the spline shaft by using the supplied bolts. Never put your hands between the disc and the valve body while the valve is working. Electrical connections must be carried out by qualified personnel only. Before doing any work on the valve and drive unit, disconnect the motor from the main supply. Follow general safety instructions. Put the valve on a level surface with a square flange down. Remove the protection from the disc shaft. Assemble the lever setting mask with a large side up using the 2 bolts supplied. Mount the lever onto the splined disc shaft, ensuring the lever is in the closed position. Fasten the lever using the supplied bolt, washer and knob. Apply a thin layer of liquid seal onto the flange to which the valve is fitted. To fix the valve, only use stud bolts that are long enough to pass through the upper connecting flange, the valve itself, as well as the lower connecting flange forming a sandwich. Otherwise, the weight below would tend to pull apart the semi-bodies of the valve. Screw on the nuts according to the supplied instructions. The inside nuts have no weight-bearing function. They only serve to secure the valve when the following feeder is stripped down. In the case of V1FS, proceed in the same way as with a V2FS, using short bolts instead of stud bolts in order to fix the valve to the hopper flange. Fix the sleeve with a hose clamp to the bottom piece of the valve. Whereas the V2FF type valves do not require any specific maintenance, the seals of the VFS and VFA valves need to be replaced periodically according to how they perform. Remove bolts and nuts which connect the 2 semi-bodies. Remove the disc together with the 2 hexagonal bushes and the seal. Remove the hexagonal bushes from the disc shafts. Detach the seal from the disc. Mount the new seal. Fit the hexagonal bushes. Mount the whole disc assembly onto the lower semi-body. Make sure that the hexagonal bushes are in the position as shown. Mount the upper semi-body. Follow the same basic procedure as with the VFS type, paying particular attention to the correct detachment and reassembly of the seal.